Hi guys, happy Monday. We are back and we are going to take some quick notes today. So go ahead and find that journal you've been using or just a piece of paper, either or. And the nice thing about having this on video is that you can pause it and collect all your materials before we have to start. So feel free at any point to pause it if you're going too fast, if you need to catch up, if you need to get materials, because you can do this at your own pace. We are going to title this page Dividing with Decimals. And we're going to start with a pretty easy problem. In fact, I'm pretty sure you can solve it in your head if you wanted to. But the big thing about this first problem is that we're going to model it, because we're really big about models and representations. That's the other half of math. You can solve the numbers all day long, but unless you can model it, unless you can understand what it looks like actually laid out in front of you, then you're missing something. So we're going to do this first problem and we're going to model it, and it's going to be a little annoying because we gotta draw all the hundredths grids, but I promise it won't be too bad. So we're going to model the problem 2 7/10 divided by 3 wholes. Okay? So I know a lot of you are already thinking, I already know the answer, I've already got it, I'm going to write it down, but just hold on, okay? Just hold on. We're going to make some grids really quick. So because we have 2 wholes in 7/10, we need to make at least 3 hundredths grids. So on your paper, go ahead and create 3 squares. 1, 2, 3. Make them pretty decently sized because, again, you're going to have to split them into hundredths, so you want them to be a good size. So to make these into hundredths grids, we need to make 9 vertical lines and 9 horizontal lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know they're not going to be perfect. Guys, look at mine. Like, don't feel bad about how yours look. Look at mine. If you want to use a ruler or the edge of a piece of paper, that'll help you get some cleaner lines too. But I'm just more so going for speed right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Last one. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I can see some places that I didn't connect, so I might go back and connect those. Okay, so we have 3 very poorly drawn hundredths grids, but that's okay. That's okay. What I'm going to do is I'm going to take a different color. I'm going to use yellow, a yellow highlighter. If you've got a highlighter, that's great. If you don't, oh well. I'm sure you've got a crayon laying around somewhere, a colored pencil. Anything like that will work. And we're going to color in our 2 wholes and 7/10. Okay? So 2 wholes means 2 of these hundredths grids are going to be completely colored in. 2 of these hundredths grids, because that's our 2 wholes, right? If we want to show a hole, we color in the entire hundredths grids. And this last grid is where we need to more so be careful, because we're only going to draw 7/10. Coloring 7/10. 1, 2, 3, 4, 5, 6, and 7. So there is that blank that's left. That blank that's left, that 3/10, we're not going to color in because we're trying to show our dividend, our 2.7 on this grid. So at this point, we can go ahead and just solve the problem with our usual long division method. So over on the side here, I'm going to do 2.7 divided by 3. But I'm moving a little far ahead of myself. I do want to estimate this problem first. Now, what would you round 2.7 to? If you had to round 2.7 to a whole number, what would you round it to? 2 7/10. Look at the grid. If we wanted that to be a whole number, would we get rid of all of this and go to 2 wholes, or would we probably just fill in this rest and get to 3 wholes? Yeah, we'd probably just fill in this 3/10, right? So it would be 3 wholes divided by 3. So what is 3 divided by 3? Yeah, it's just 1, right? So we have our estimate. Our estimate is 1 whole. Now that's not our answer because we actually need to solve for our answer, but we know our estimate is 1 whole. And now we can actually solve. So when your divisor, the number on the outside, doesn't have a decimal in it, that means you can take the decimal in your dividend and just drag it straight up. Drag that decimal straight up into your divisor. I'm sorry, your quotient. So, 3, can 3 go into 2? No. 3 can't go into 2, so I put a 0 here. 3 can go into 2 0 times, pretty much. Now, I combine the numbers. Can 3 go into 27? Well, let's skip count. 3, 6, 9, 12, 15, 18, 21, 24, 27. Yeah, 3 can go into 27 9 times. So I put a 9 up here. I subtract out 27, and it's a 0, meaning I'm done. So we got our answer. Our answer is 9/10. And again, I know a lot of you are like, oh my gosh, I've already had that answer since you practically wrote down the problem. I know. It's not about getting the answer. It's about being able to model the question, though. So if I wanted to model the fact that 2.7 divided by 3 equals this, what I need to do is divide this model up into 3 sections. Each section should contain 9/10. So maybe I'll use a different color. 9/10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. It would go right about there. So there's one group. And there's 1/10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I would go to right about there. That's my second group. And now my final group. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see how each group has 9/10 in it? I've taken 2.7 and divided it into 3 equal groups, each containing 9/10. That's how you model these type of problems. I know it's not necessary. I know you can just do the math without the modeling, but the modeling is important. You're going to see it in other places, so you need to be prepared for it. All right. I promise. The next problem won't have modeling. So go ahead and, after you're done with that, and again, feel free to pause and catch up whenever you want, because I know I'm moving fast. I'm just trying not to make this, a 25-minute video. But you are free to pause at any time and do whatever you need to do to catch up. All right. The next problem we're going to solve is a little bit bigger, so we're not going to use modeling because it would be impossible. It would be pointless. We're going to do 427.8 divided by 12. So yeah, pretty substantial, pretty big division problem. But don't worry, because your divisor doesn't have a decimal in it, it's as easy as just regular division. So to solve this problem, you're going to set it up like a long division problem. You're going to put the dividend inside of the box. 427.8 goes inside the box because it's the dividend. And 12, the divisor, goes outside. Okay? So the thing about long division is that it's wonderful, it's great, but there's one rule. You have to get as close as possible to the number or the whole thing breaks apart, right? We've talked about that before. So when I start to solve, I go from the left side and I go a number at a time. Can 12 go into 4? No, 12 can't go into 4. Can 12 go into 42? Yeah, 12 can go into 42. Now, it might not go perfectly, but it'll go into 42. How many times do you think? How many times does 12 go into 42? Well, to solve it, you probably have to skip count. 12, 24, 36, 48. Well, hold on. 48 is too much, so you have to go back. Go back to the 36. So it goes in 3 times. And I'm not going to put the 3 above the 4. The 3 goes above the 2 because that's the last number I used. Oh, and I forgot. Pull that decimal up. So put the 3 here. And then we're going to subtract out the 36. From 12 times 3 equals 36. So what is 42 minus 36? And don't be sitting there doing the, oh, I got to carry one from the 4. No, 36 and 42 are close enough together that you can just count. 37, 38, 39, 40, 41, 42. They're 6 apart. So you put the 6 here. Now, that's good because 12 can't go into 6. That's what's supposed to happen. So now you pull down one number, only one number. You get a 7, 67. Okay, well, yeah, 12 can go into 67 for sure. It might not go in perfectly, but it should go in, right? And again, this takes some skip counting. So, of course, you're free to, on the side of your paper, do some addition. 12 plus 12 is 24. Okay, 24 plus 24 is 48. If I add another 24, I think it's going to go over 67. Just from thinking about it. So maybe I'm not going to do another 24. I'm just going to do a 12. And that would be 60. Yeah, so if I add another 12, it's definitely going to go over. So how many groups is that? How many groups did I create here? 1, 2. That's 2 groups. I doubled it, so that's 4 groups. And then I added another group. So how many groups is this 60? 12 times what equals 60? Right, 5. So the 5 would go up above the 7 because that's the last number I used, and I would subtract out 60. Pull down the 7, and now pull down the 8. Okay, last one. And that's what's great about having this math here on the side. Now you're ready to keep going to 78, right? Because I can see 60. I can keep going to get closer to the 78. What's magical about this, guys? Have this math along the side. It helps so much. If I do it, you can do it. Okay? Let's add another group of 12. Okay? 72. Okay. If I add another group of 12, do you think it's going to go over? Yeah, I think so too. So I'm not going to add another group of 12. I'm going to stop here. If this was 5 groups and then I added one more group, how many groups is this? All right, 6. So I'm going to subtract out 72. What's 78 minus 72? That's 6. And again, we use 6 groups to get this, so don't forget to put your 6 up here above the 8, because that's the last number we used. So I have a 6 left, and you might be thinking, okay, well, that's just the remainder. Not quite. We don't really do remainders when we're working with decimals, right? That's more 4th grade stuff. We're past all that. Instead, we know that we can just keep going by adding a what here? Behind the 8. What can we add? A 0. By adding a 0, we can keep going. So if I add a 0 and pull it down, I get 60. I've seen that number somewhere, right? I've already seen that number. 12 goes into 60 how many times? It's right here. 1, 2, doubled it was 4, and added another group, 5. 12 goes into 60 5 times. Subtract out the 60, 0. And that means you're truly done, right? And again, if you're feeling at all like you're unsure if you did it right, if you're unsure if your answer is, you should be estimating. We didn't estimate before this problem, and that's going to happen, right? You're really eager to do the math. You're not estimating first. It's okay. By the end of it, catch yourself and know to do the estimation at least some point during the problem. It can be before or it can be after. It really doesn't matter. As long as you do the estimation, you'll catch whether the math you're doing is correct or whether there's maybe an error somewhere. So let's look at 427.8. Whew, that's a pretty big number, right? What would you round that to, you think? What would you round that to? I'm thinking some of you are probably going to say 430, because we'll just go ahead and go to the tens place. Some of you might even be saying just flat 400. Either or works. We want the answer to be as easy as possible. So let's say 430. And we don't have to leave the 12 alone either. Even though the 12 is already a whole number, who says we can't change it? Nobody. It's our estimate, right? We can do whatever we want with it, as long as we don't go too far from the number. So let's change that 12 into a 10, because 10 is a really easy number to work with. So what would 430 be if I divided it by 10? If you're thinking 43, you're right, because 10 times what equals 430? It's 43. You can always take a division problem and reverse it into a multiplication problem. So if this is our estimate, 43, then our answer, 35 and 65 hundredths, really isn't that far off. It seems like it's not that close, but in reality, it's not very far. 43 and 35.65 are pretty close. So that's how I know my estimate is good. Now, if I got an estimate that was in the hundredths, or if I got an estimate that was in the ones, then I might be rethinking some of my math up here. But because my estimate was pretty close by, not exact, but pretty close by, I'm going to go ahead and, accept that that is a correct answer. And I know I did all this math correctly. I can check through and make sure that that's all correct. Okay? That's it for today's lesson. Thank you guys so much for joining me, and I hope you have an awesome Monday. See you later.